Today we learned about the trigonometry ratios, and they will be the third tool in your toolkit. So far we have learned 3 ways to solve triangles. The first one here is called Pythagorean theorem. So let's say we have this side here and this side here. Let's call this one side or leg A. Let's call this one side or leg B. And let's call this one across from the 90-degree angle C or the hypotenuse. There is a relationship between the sides in a right triangle where A squared plus B squared equals C squared. So when do we use this tool? If we have 2 sides and we need to find the third. Now the second tool we learned were special triangles. So in certain special right triangles, there is a relationship between the angles and the sides. So if we're given angles 45, 45, and 90, we know that the sides are x, x, and x square root of 2. The sides across from the specific angle are dictated by the angle. So if we have angles 45, 45, and 90, the sides will be x, x, x square root of 2. Same thing with this other type of special triangle. There is a relationship between the angles and the sides. If we're given 90 here, 30 here, and 60 here, certain sides are across from the angles. So across from 30 we have y, across from 60 we have y square root of 3, and across from 90 we have 2y. So if we have the angles 30, 60, and 90, we know that our sides are y, y square root of 3, and 2y. So when do we use special triangles? When we have 45, 45, 90, or 30, 60, 90 as our angles, and we have one side given. And the third tool, trigonometric ratios, is what we will learn about today. So this is just a summary of the review we just went over. Write and draw a triangle when you use Pythagorean theorem. So if they give us a right triangle with 2 sides, and the last side as the unknown, we would use the Pythagorean theorem. So when we have 2 sides and we need to find the third, we use the Pythagorean theorem. Number 2, write and draw a triangle when you use special triangles. So, if we are given the following, or we use special triangles when we are given special angles 45, 45, 90, or 30, 60, 90, and one side. So when do we use trigonometric ratios? We use trigonometric ratios for any angle that's not a special angle from special triangles. Yeah. And we are given one side. So what I mean is, if they give me a 90-degree angle here, and they say this angle here is 64, and they give us one side here, there's a way to solve this triangle, and it's using trigonometric ratios. So let's explain the trigonometric ratios. We're going to go back to the first page. So the trigonometric ratios explain the relationship between sides and angles. So let's say we start with a triangle here. And the angle that they give us, I'm really struggling drawing this triangle here. Okay. And the angle that they give us is right here. And it's 35 degrees. Right? This here is 90. And then they give us one side measure. Let's call this 8. Right? So in trigonometry, there are ratios that have been found where the ratio of sides to an angle, or a reference angle, are always the same for certain degrees. So let's say we are given this triangle here, right? 35 is our reference angle. In all triangles, the angle across from the side across from the 90-degree angle is called the hypotenuse. The side across from the angle we're referencing is called the opposite side. And the adjacent side is the side right next to the reference angle. So there are 3 known trigonometric ratios. They are sine, cosine, and tangent. If we find the ratio of the opposite side to the hypotenuse side of the given reference angle, we can solve for the missing side. In cosine, if we are given the opposite side, or if we are given the adjacent side now, and the reference angle, we can find the hypotenuse. And in tangent, if we take the ratio of the opposite side over the adjacent side of our 35-degree reference angle, we can solve for the missing side. The missing side. So basically we're saying, given any angle, the sine of any angle is equal to the ratio of the adjacent to the hypotenuse side. The cosine of any angle is the opposite to the hypotenuse side, and the tangent of any angle is equal to the opposite over the adjacent side. So how do we solve a trigonometric problem? Let's look at the sample problem here. First, we name all the sides. So the side across from 90 is always the hypotenuse. The side across from the reference angle is the opposite. And the side next to the reference angle is called adjacent. Now we write our acronym SO, CA, TOA, and this will guide us what to do. So now we look for the sides that give us information in the problem. The problem labels this one here, opposite, and adjacent. So I know and I'm going to be using opposite and adjacent. And that's in tangent. So I know now that I'm going to be using the tangent ratio. Oh, it's too close to the eraser, it won't let me make the circle. But here, I'm using the tangent ratio. So the tangent of 24 degrees is equal to opposite over adjacent. And now I just substitute the values that I found above for opposites and adjacent sides. So the tangent of 24 degrees equals opposite side x over the adjacent side, which is 19. Now I have to get rid of the fraction. So I get 19 times the tangent of 24 degrees, which is x. I put this part here into my calculator, and I get x equals 8.45. So this side here is 8.45. Let's do another example here. So I name my sides first, according to the angles. Across from the right angle, I have my hypotenuse. This is my reference angle. The opposite side from my reference angle is 12, and the adjacent side is here. I write my acronym, SOHCAHTOA, and I look for the sides where they give me information. So they give me information here for the hypotenuse, and information here for the opposite side. I look for OH up here. OH is here. I'm going to use sine. So the sine of reference angle x is equal to opposite over hypotenuse. And now I substitute for the values in the triangle. I get the sine of x degrees equals side 12, the opposite side, over side 17, the hypotenuse. Now, if I ever have x as my angle, I need to use the sine -1 function on my calculator. So usually you have a button for sine, and then if you hit second, you'll have the button for -1. You'll have the button for the inverse of sine. So we get sine -1 of x equals 12 over 17. Put this part here in your calculator. Hold on. Put this part here in your calculator, right? You get sine -1 of 12 over 17, and you'll get your answer, which is 44.9 degrees. So angle x equals 44.9 degrees. So the big thing from this problem here was that if you don't have x, if you have x as the reference angle, you use sine to the -1. Let's solve one more problem. So we name our sides according to the angles. This side here is the hypotenuse. Across from the reference angle on the opposite side, we have our opposite side. And next to the reference angle, we have our adjacent side. I write my acronym, SOHCAHTOA. And I look for the sides that give me information. So here they tell me that this side is 60, and I'm looking for, oh, I guess it got erased, but I'm looking for this side here, which is x. So now I'm going to look for a and h in my ratios. I have a and h right here. I'm going to use cosine. So I get the cosine of 62 degrees equals adjacent over hypotenuse. And I get the cosine of 62 degrees equals x over 60. So now I need to get rid of my fraction. And I get 60 times the cosine of 62 equals x. So I plug 60 times the cosine of 62 into my calculator, and I get x equals 28.2. Now, what if I had the same problem, and they give me 60 here and x here? So I do the same thing. I name my sides according to angles, right? If the side across from my reference angle is going to be the opposite side. The side adjacent to my reference angle is going to be here. I write out my, ooh, that's sloppy, sorry. I write out my acronym, right? And now I look for the information they give me. They give me this side here, which is the opposite side, and they give me x here, which is the hypotenuse. I look for opposite hypotenuse, and I get this one here, and this one here. So I'm going to use sine. So I get the sine of 62 equals opposite over hypotenuse. I substitute my values, and I get the sine of 62 degrees equals
sine of x, no, sine of 38 is the sine of the angle.
60 over
The
x.
angle is x.
So now I solve
Like in here.
my fraction, and I get x sine of 62 equals 60. Now I divide both sides by the sine of 62. This here cancels, and I get x equals 60 over the sine of 62. And I plug this part into my calculator with the denominator in parentheses. And that's what happens if you get x in the denominator.